Hi everybody, welcome back to Mr. Carroll's Classroom. Today we're going to talk about quadratic inequalities. So let's go ahead and get started. Alright, let's start off with a quadratic equation, which I know this is a quadratic because the degree is 2, or the highest exponent, and it's an equation because we're using the equal symbol. And so if we were to graph this, we'd end up with this parabola here. And we're going to talk now about the really two types of generic questions that deal with inequalities with quadratics. So let's go ahead and bring up the first one. So you may have already seen this first type of inequality, and this is the exact same expression over here. However, I'm now saying that it's less than 0. So what I actually removed here is the two-dimensional aspect of this problem. There is no longer a y in this question. This is a mathematical question, this inequality. It's saying, hey, where is this expression less than, if I evaluate it, where is it going to be less than 0? In other words, what values of x can I plug in here where this side is going to be less than this side? And so there is no y involved here. However, we're smart people. We can think of this as a two-dimensional type of problem because we literally just showed, hey, if this 0 was a y, then it would have this nice parabolic shape. So let's break down what this is actually asking. Well, instead of this being less than y, it's less than 0. In other words, where y is 0. And in a two-dimensional graph, where is y equal to 0? Well, that is literally the line of the x-axis. Where y is equal to 0, that is the x-axis. So this is actually asking, where is this left side less than or below the x-axis? That's actually what it's asking. However, we have to keep in mind that even though we can think about this as in a two-dimensional space, this is a one-dimensional question. So our answer should be one-dimensional, meaning it's only going to be along the x-axis. And you can kind of imagine the x-axis, like if you just collapse the y down, the x-axis as the number line, okay? And that's because that's how you typically answer these. You can answer them as a number line or an interval notation or inequality notation. But two-dimensionally speaking, it would actually look something like this. I could plug in anything in this range because remember, the y's actually don't matter in this question at all, right? It doesn't matter if I chose a point up here or down here. It's still the same x value. So what you should imagine is taking the y out of this completely. All the y up here and down here is gone. You can think of it as all collapsing onto the x-axis. So we're literally just looking at the x-axis or the number line here. And so the answer to this lies between the points on the x-axis of 1 and 4. And notice we don't include 1 and 4 because we're not asking where is it going to be equal to 0 or where does it cross the x-axis. It's where is it less than that. So we have these dotted lines here. That's why. Okay. But ultimately our answer would be a one-dimensional answer, essentially the interval from 1 to 4. Okay. Not including those endpoints. All right. So let's bring up the second type of question, which you may have not seen before. So the second type of question is going to look very similar, except instead of saying, hey, where is this expression on the left less than 0, we're saying, hey, where is this less than y? Now, this is a much more difficult question to answer, or at least it's a much more difficult answer to express. And that's because the one up here, yeah, you can express this since it's one-dimensional as an interval notation or just as an inequality. But down here, there's really only two ways to express this answer, and you're looking at one of them. This algebraic expression, that's literally a solution, right? That is a solution or of the situation we're trying to show. Okay, but we can also express this graphically as well. Okay, so what is it going to look like? Well, in this case, it looks like this. So that looks a lot different than before. Now we are keeping the two-dimensional aspect of this. Why is that the case? Well, because in the original I have both x and y, so I can pick any x and y, any ordered pair, any point, and I can test it, right? I could pick a point over here, I could pick a point down here, I could pick a point in here, and we could test it. If I plug in that x and that y, either you're going to get a true statement, meaning the number on the left is going to be bigger or smaller than the number on the right, or you're going to get a false statement, meaning either you're going to get equal numbers or something that is not less than the thing on the right, okay? But what we have to do to figure out which side is shaded is simply pick a point and plug it in, right? Actually, in this case, it would be easiest to plug in the point 0, 0, and if I did, this x squared would be wiped out, the minus 5x would be wiped out, and I just have 4 on this side. And over here, I'd have y is equal to 0. So is 4 less than 0? Well, no, that's a false statement. So, and that's going to be true for anything on this side of the curve. So once you get one false, you know they're all going to be false, which means that this side has to be the true side. And you could then go ahead and plug in a point just to verify, but it will be, if this side's false, the other side will be true, meaning any point on this side of the curve will give you a true statement here, meaning the left side is going to be less than the right-hand side, okay? Do we include the curve here? You might not be able to tell. It's kind of hard to tell, but this is actually a dotted line. There's little green specks. I don't know if you can see that in there. But this is actually not including the curve. Because what is this parabola? What is that? What does it mean to be on the curve? Well, that is a solution to this guy right here, where the left side is going to be equal to the right side. That is not what this is asking. This is asking where it's less than. However, that being said, we do follow our normal rules, right? If it's less than or greater than, then we do not include points on the curve. But if it is less than or equal to or greater than or equal to, we do include the curve because we're including where the left side is equal to the right side, which is the actual curve itself, okay? All right, so there you go. So remember, just to recap, this one on top is really a one-dimensional question, and so our solutions are going to be one-dimensional, meaning just on the x-axis or the number line. However, we can think of it in a two-dimensional manner to try to wrap our heads around what the question is asking. In other words, in this case, this is asking where is this underneath the x-axis. And then this one here is a two-dimensional question because it's involving an x and a y, so we have to test a point and just figure out which side is makes this inequality true. Okay. All right, so let's go ahead and practice this. All right, so here's my first example. And let me go ahead and grab a color here for ourselves. Okay, looks good. Okay, so first of all, let's just talk about what this is asking. This is not just 0 over here, so it's not just saying, hey, where is this above or below the x-axis? This is a two-dimensional question, right? What point x and y, or points, if I just pick a bunch of points anywhere on here, where are these points going to satisfy this inequality? Okay, well, first we got to figure out those boundaries, right? And what is the boundary? Well, that's the parabola itself. So we have to graph this thing. So let's go ahead and graph it. All right, so in order to graph this, there are going to be a couple of major pieces. The first is going to be, I guess we'll go ahead and do the x-intercepts first. So in order to do the x-intercepts, we're going to set it equal to 0. So x squared minus 5x plus 4 is equal to 0, and we're going to factor. And when we factor, we'll use guess and check. So I have x, and I have two numbers that multiply to 4 and add to negative 5 are going to be negative 4 and negative 1. And now I have two things multiplied by each other equal to 0, so that zero product property tells us I can separate them out and set them both equal to 0. So x minus 4 is equal to 0, and x minus 1 is equal to 0, which means x is equal to 4 and x is equal to 1. Those are the x-intercepts. So let's go ahead and plot those on here. So I have x is equal to 1, and x is equal to, negative 1, and x is equal to positive 4. 1, 2, 3, 4. Okay, perfect. Now, the next step here is to get the vertex, and it's going to lock this thing in, because I don't know if this thing looks like this, or if it looks like this, or if it looks like this. Not really sure, right? But we can grab the vertex to lock that in. So to figure out the vertex, I'm going to go ahead and erase my work here, actually, so we have more room, because this particular problem is going to involve a little bit of work, it looks like, to get that vertex. We're going to have to deal with some fractions. So anyways, to get the vertex, let's first get the axis of symmetry, the line that goes right in between, which actually I can already tell that it's going to be at 1.5, but let's go ahead and verify that. All right. Let's see here. So our x is going to be negative b over 2a. That's our formula for the axis of symmetry, which is equal to negative 5, which is positive 5, all over, let's see here. I think I actually messed up on my x-intercepts. I did mess up on my x-intercepts. I'm sorry about that. Let me go ahead and fix that. I can't remember if I just did the math wrong or not, but when I factored that and got the x-intercepts, it looks like it definitely should have been x is equal to positive 1 and x is equal to positive 4, which puts my my axis of symmetry at 2.5. Anyways, so, and that's actually a good note there, right? You can actually use a lot, like future steps, to check your old steps, right? I know that it should be halfway in between, and if it was halfway in between, I would have gotten a different answer here, because 5 over 2 is 2.5, right? And so now it looks like I am correct. So there we go. All right, we're back on the right track here. But I need the vertex, or the y value, for that axis of symmetry. Let's go ahead and just I'm just going to shade in that axis of symmetry here. Not that it's really a part of the graph, but anyways, so what we need to do is we need to plug in 2.5 for x, which that's what I said here. It looks like we're going to have some fractions. So I'm going to plug in 5 halves because it's easier to do math in my head with fractions rather than I'd have to use pretty much a calculator for if I use decimals. But anyways, so let's go ahead and plug in 5 over 2. So that's 5 over 2 squared minus 5 times 5 over 2 plus 4 is equal to y, because that's what we're solving for, right? All right, let's go ahead and simplify this. So 5 over 2 squared, well, that's 5 squared over 2 squared, which is 25 over 4, minus 5 times 5 is 25 over 2, plus, and I'm going to write this as 4 over 1, just because I know I'm going to have to combine all of these. So we get to practice our fractions a little bit here. So in order to add or subtract fractions, we have to have a common denominator, which means that my common denominator between 4, 2, and 1 is going to be 4. So this one is all good. So I have 25 over 4 minus, now I have to multiply top and bottom by 2. So that's going to be minus 50 over 4. Plus, and I'm going to multiply top and bottom by 4, or 16 over 4. Excuse me. And now we have a common denominator, so we can go ahead and combine these. So combine the numerators. So 25 minus 50 is negative 25, plus 16 is going to be negative 9 over 4 is equal to y. And what is negative 9 over 4? Just so I can graph this, that looks like 4 goes into 9 twice to get 1/4, so that's going to be negative 2.25, it looks like. Okay, so the vertex here. The vertex is going to be at, our x value was 2.5, and my y value was negative 2.25. Okay, so here we go. So let's see here. So we're going to go over in the x, 1, 2.5, and then down 1, 2, and then 0.25 about here. Okay, there we go. So let's go ahead and just kind of do the best we can with our parabola. Looks more like a V, but that's okay. All right, so here we go. So now the next part is going to be to determine should we include our parabola as solutions, and also which side should we shade. So first of all, this is greater than. It's not greater than or equal to, so we're not including where that left side is equal to the right side. So this is going to be a dotted line. So I'm going to kind of cheat and just kind of erase what I drew here to make this dotted. Sorry for following along and used a pen. Okay, so we're not going to include that. And then the last step is really just to determine which side needs to be shaded. So let's go ahead and figure that out. So I'm going to go ahead and plug in 0, 0, since that's not on the curve. And so if I plugged in 0, 0, I actually don't even have to write this out. It's that easy. So that would be 0 minus 0 plus 4. So that's 4 on the left side, and then 0 on the right side. So is 4 greater than 0? Well, yes, that is true. So we would go ahead and we would shade all on the outside of this curve. So I'll do the best I can to do that. So you could pick any other point if you wanted to verify, but anything on the outside of here would satisfy this inequality over here. Okay? All right, let's move on to the next one. All right, so here's another problem, and let's just figure out what is this actually asking us. So in this case, notice there is no y in this inequality. So this is a one-dimensional problem, but we're going to think of it as if it's a y. In this case, it's just where y is 0. In other words, the x-axis is where y is equal to 0. So this is really asking, where is this side less than or underneath 0, so or underneath the x-axis. So once I graph this thing, essentially wherever this is underneath, but only in the x, is going to be where my solutions are. Okay, so let's go ahead and figure this out. All right, we are going to again do our graphing here. So the first thing I'm going to do is I guess we'll go ahead and factor it again to get the x-intercepts. So I'll set the whole thing equal to 0. So that's 0 is equal to negative x squared minus 2x plus 3. And I really hate when there's negatives out in front of my leading term. So I always get rid of them by multiplying both sides by negative 1. 0 times negative 1 is just 0. And then negative 1 times this whole side, well, all the signs are going to flip. So that's positive x squared plus 2x minus 3. Okay, let's go ahead and factor by guess and check. So I have x times x, and I have two numbers that multiply to negative 3 and add to positive 2. That's going to be plus 3 and negative 1. And set both of these equal to 0. X plus 3 is equal to 0, and x minus 1 is equal to 0. Solve for x. X is negative 3, and x is 1. And there we go. We have our x-intercepts. Let's go ahead and plot them. Got 1 and 1, 2, 3. Oops, sorry. 1, 2, 3 is negative 3. There we go. All right. Next up here, we are going to go ahead and figure out the. We technically don't even need the vertex actually. So you know what? Well, I guess we'll find it. We might as well. This is actually going to be an easier one. So let's go ahead and put it in there. But technically, it doesn't really matter. Like what we're interested in is, hey, is this section going to satisfy the inequality, or is this section going to satisfy it, or is this section going to satisfy it, right? That's what we're actually interested in, since it's a one-dimensional problem. But let's go ahead and figure that out, what the vertex is. So I'm going to go back to the original. I'm going to go ahead and plug in negative b. So that's x is equal to negative b over 2a. So that's negative 2 is positive 2 over so negative b over 2a. 2 times negative 1 is negative 2, which is negative 1. So x is equal to negative 1. And if I plug in negative 1, let's go ahead and plug that into the original. So that would be y is going to be equal to negative 1 squared minus 2 times negative 1 plus 3. Which means that y is equal to, well, negative 1 squared is positive 1. Negative 1 times negative 1 is positive 1. But then I have to multiply it by that negative out front. So that is still negative 1. And then negative 2 times negative 1 is positive 2 plus 3, which means that y is equal to negative 1 plus 5, which is positive 4. So the vertex is equal to the x value of negative 1 and the y value of positive 4. All right, that was a lot easier because there were no fractions. So let's go ahead and plot it. So -1 and then +4, 1, 2, 3, 4, about right here. And so let's go ahead and, oh, you know what? I think I'm going to change this just to make it a little bit different. This one is 0 is greater than. Let's change it to greater than or equal to, just to make it different. Different than the last one, at least. All right, so if it's greater than or equal to, we are definitely going to include our line, so, or our curve, I should say. It's not a line, it's a parabola, so it's a curve. Let's go ahead and graph this, and we're going to keep it solid because of that change I just made. All right, so the next step here, the last step, is really just to determine which side is meets the requirement here. And again, you could actually plug in anything you want just to test it, and you would know. But I'm just gonna say, hey, this is saying, hey, where is this? Where is this less than or equal to 0? So it's actually gonna be everything. Oops, actually, let me go ahead and 1 second here. So it's actually gonna be, this is below, and it goes down all the way to -infinity, and this is below as well. But again, we're not talking about y here, right? This is a one-dimensional question, so it's only in the x that we're worried about here. So it is on the x-axis, since this goes forever that way. It's from -infinity. Let's go ahead and start writing this answer here. So it's where x is equal to, from -infinity, we don't include it, all the way up to and including -3. Whoops, we want to include it. Union, because we're going to have another piece to this, from +1 up to, and this goes on forever actually in the x, even though it doesn't, it kind of looks like it might kind of stop, but it actually keeps going off to the right forever and ever and ever here. But anyways, so it's going to be to +infinity. So there you go. So x is equal to these two ranges, I guess. All right, these two intervals, we'll say, satisfy this question here. Okay, a one-dimensional answer to answer a one-dimensional question. However, we thought about it in a two-dimensional way. So kind of interesting. All right, there are other ways to answer this. Another way to do this would be to, forget about the actual graph itself. You could have literally just said, hey, where does it cross the x-axis, and then test points. Okay, and that's a common way that we do it as well. In fact, we went over that in a previous lesson. Okay, so you could just go ahead and say, okay, let's go ahead and plug in an x over here, and if it's true or false, or if it's true, then we know it's a part of our solution set, and then we would just test each interval. That's it. Okay. Okay, so let's continue. We have another question here, last one. Here it is. And actually, this is the exact same question as before, which is why I wanted to make sure I kept my work, actually. It's the exact same question as before, except now we have this g of x. So what the heck is this g of x? Well, g of x is the same thing as y, right? So this is a two-dimensional question, no longer a one-dimensional question like before. So, but we would go ahead and we would actually do the exact same process to graph this thing, right? We would figure out the x-intercepts and also the vertex. And then the last piece of this is going to be, hey, where is this, this true, I guess. If I plug in a y value and an x value, or any ordered pair, pick your points anywhere. It could be here, it could be here, it could be here, it could be anywhere, right? But we know that if one's true on the outside, they'll all be true on the outside. If one's true on the inside, they'll all be true on the inside. But first, before we even do that, do we include the curve? In this case, since I made that change, we are including the curve, because we're not just saying, hey, where is this greater than that? It's greater than or equal to, and the curve represents the equal piece. All right, but now we got to figure out the greater than piece. So let's go ahead and test a point. So I'm going to, again, test 0, 0 here. So if I plug in 0, 0, that's going to be 0 on the left. And over here, this is going to cancel, this is going to cancel, and I'll get 3 on the right. And so is this true? Is 0 greater than or equal to 3? And the answer to that is No, it is not. So that cannot be a part of the solution inside of here. So since this is not a part of the solution, none of this is a part of the solution, which means the outside is going to be where our solution lies. So let me pick the right size here, and I'll try to do my best in shading. Whoop, kind of overlap there, but that's okay. All right, so everything on the outside there. That's a terrible shading job. But anyways, okay. All right, guys. So there you go. There is our lesson on quadratic inequalities. You can see that the questions really come in two different flavors there. One is really a one-dimensional type of problem disguised as two-dimensional, or maybe it's two-dimensional disguised as one-dimensional. I don't know how you want to put that. But the other one, when the y is included, that is definitely a two-dimensional question there. And so we have to answer those in very different ways, because one of them is just answers along a number line. Then the other one is answers on a Cartesian plane or an XY axis, which is really like how do we express those solutions without a graph? I can't think of one. So anyways, all right, guys, hopefully you got something out of this lesson, and hopefully you enjoyed it, and I will see you in the next one.